Cool. All right. We are now working on elasticities. So, elasticities is the third of our four parts. The fourth part is pretty quick. I think the fourth part should take us like 10 minutes. So, let's just talk quickly about elasticities and wrap this chapter up. Elasticities are pretty cool. Elasticities are, it's pretty convenient to be able to summarize the responsiveness of a variable to a change in another variable using a summary stat, right? We wanted to know whether the increase in the price, to do like what that affected on price and quantity. We were able to do that. Often we have reasonable estimates of these summary stats, so we can use to predict what will happen in the market. But um, oftentimes we have different units. And so what happens if we're dealing with like a $1 change and we're dealing with tons? And so often what economists will do is that rather than looking at like total units, we'll look at marginal units. And so we'll look at percent changes. And so that's where elasticities come in, is that elasticities really kind of capture the fact that shapes and positions of demand and supply curves determine how much of a shock affects the equilibrium price in our quantity, right? And so we're going to be given the same shift in supply. How do different shapes of the demand curve affect the P's and the Q's? Sorry, I don't have this graph. We're going to like cut this out. Um, is given the same shift in the supply curve, like we're going to affect the quantities differently, right? So if we imagined this graph. I guess we'll just do the graph. Even though we didn't have it, we'll do it. Right? Let's say that this is what our demand curves were shaped like. Or here, let's say that this one is really, really like we don't want them both steep. Let's say that it looked like this. If we had a 1 unit increase in supply, right? Our price is not going to change that much. And our quantity demanded is going to be a lot. I mean, that would be our change in our demand. Sorry, not our supply. Now, suppose the same thing happened for a change in supply, about the parallel same length. Notice that our change in our quantity demanded is far less, but our change in our price is far more. And so these all depend on the shapes of the supply and the demand curves, and that's exactly what the elasticities tell us. And so we're going to define a couple of terms like unit elastic, perfectly elastic. Um, if you really don't want to care about elasticities, that's fine. This is often how we decide who bears most of the burden when we put on a tax. So you've probably learned in your principles class that when you put on a tax, if supply and demand both have the same shape, that typically it doesn't matter who the tax is placed on, the equilibrium is going to adjust the same. If you care that the curves change, notice that the equilibrium will also change, even if we put the same direction and we had the same shift. So elasticities matter. Bear with me, they're pretty easy. So we should be able to kind of cook through this a little bit as soon as we can kind of like get our feet underneath us, right? So moving from 1020 to 1030, I mean to 3020, in elasticity is just the percent change in one variable over the percent change in another, right? And so there's going to be a lot of these, right? We're going to look at maybe like the percent change in quantity demanded following a percent change in price, right? We could also think about the percent change in quantity demanded following a percent change in income, right? So how much would our quantity demanded increase if the price, I mean decrease, if the price increased by 1%? Or how much would our quantity demanded increase in percentage terms if our income increased by 1%? These are all questions that elasticities will answer. And really, it's just going to be Z1 minus Z0, like our original, over our original. And then it'll be X1 minus X0. That's how we would have done it in 1020. But now we've gained access to this cool thing. This would be like we would need a discrete change. And that's good because this discrete change helped us kind of get the general direction. But what if we wanted to know exactly what happened? That's where we're going to use our partials. And our partials are going to say, what if we had just the smallest minutia change in X? What would happen to Z? And notice when you're dealing with this, that these terms flip, right? This X and this Z flip. So this is what we're going to get into our first one. This one is called the price elasticity of demand. The price elasticity of demand is exactly what we'd used for our first example, is what happens to the quantity demanded following a percent change in price, right? And it measures the responsiveness to consumers to changes in the price of a product. So if you wanted to think about something that is like entirely needed, right? Think water. Regardless of the price of water, we're always going to buy water, right? So our elasticity of demand, our price elasticity of demand for water is going to be relatively small. But if we think about something that is like what we call an inferior good, our price elasticity in exchange for like a cup of noodles is going to be a lot higher for when price changes, and it's going to decrease a lot, right? And so that's what these are going to be given. And again, it's also important to note that these can change along a given price, right? These are fixed. We're not just looking marginally, we're also combining totals. So this should also be that what we're looking for more so is that we are thinking about like what if price was equal to 1 or what if price was equal to 10? The price elasticity of demand could change. Okay, so let's think about this in theory, right? What is the price elasticity of demand and quantity for this given function, right? So if we wanted to say this, right, we want to know the price elasticity, we want to know this over P, right? And so another way to think about this is we want QD over P times P over QD, right? And so in theory, right, our epsilon, and we're going to call this, I know this was an E, we're going to call this epsilon, right? That curvy E is an epsilon. It's often used to denote price elasticity of demand. Um, the partial of D with respect to P, I mean of QD with respect to P is just minus B times our price over our quantity. And so this is just the elasticity of demand. That's it. That's it. That's price elasticity of demand. So easy we could do it in our sleep, right? So now let's put it in practice. So we've got Q is equal to 120 minus 2P plus 4Y, and we want to know what it is at P equals 10 and Q equals 20, right? So we want, again, this formula here. So let's do it one step at a time. We know that this partial derivative is just imagine this term wasn't here. What's the derivative with respect to P? Oh, well, it's just minus 2. And then we're given these two values to fill in here. So we're going to go 10 over 20. So this should be minus 2 minus 0.5, which should equal minus 2.5. Oh, shoot, not, sorry, my fault. These should be multiplied together. I was like, that's not right. That's not right. That's my fault. This should be minus 1. Same thing, right? This is still 0.5. So minus 1, right? And so that's it. That's the price elasticity of demand for this function. So if we want to think about this, right, imagine that we had this demand curve, right? And we had this, it was here, right? And we wanted to figure out what were the elasticities along this line. So I'm sorry. I'm gonna redraw this for a second. Boop. Right, so let's say that this is 12. Say for ease, this is 12. This is our price. This is our quantity. And then let's say that at 9, at 6, at 3, and at 0, we are interested. And then this is going to be also 9, 6, and 3. So we're going to have a pretty straightforward, right? So let's say that our slope is constant, right? Our elasticity is not. So if we wanted to say that this was like at price equals zero, so right, so we're going to be at this point here, right? Regardless of what our A is, our elasticity is going to be zero. And so what that means is we are going to be perfectly inelastic. Now, let's put this box around here, right? I'm going to copy this because we're going to be moving this down as well. At price equals 1, or here, let's say at price equals 6 and quantity equals 6, our elasticity is going to be minus B. Sorry, that's my fault. I stole these slides from somebody and I must have forgotten to change this part here. So if we wanted to do this, right, we would do this as, or sorry, this should be minus 1, right? Because our slope here was 1. And so at this point here, our elasticity is minus 1. And so that means that in between here, our elasticity is greater than minus 1, but less than 0 still. And then we've got one last thing that we're going to need to do is what happens if we were at the other endpoint, right? If we're dividing by 0, then this elasticity here should approach infinity. And so this elasticity here is going to be less than -1. And what we call here is this is perfectly elastic. This is going to be called unitary. We're going to consider anything in between elastic. This is perfectly inelastic. Oops. And this, anything in between, is inelastic. So, to summarize, right, if epsilon is equal to 0, the demand curve is perfectly inelastic at that point. So this was at Q equals 0. I mean at price equals 0. My fault. Anywhere in between is going to be the curve is inelastic. If epsilon is equal to -1, it's unitary. If epsilon is less than -1, it's going to be elastic. And this at perfectly elastic at that point is going to be at Q equals 0. Okay? There are a couple other elasticities that we have. We have a constant elasticity of demand. Constant elasticity of demand is kind of a weird one. But typically, we just take this as a log linear form, right? So we take the logs so that we can pull this alpha down in front, right? So then to find the partial of Q with respect to P, right, we just take the derivatives with respect to P. So we take 1 over Q, dq dp, should equal alpha over 1 over P d what? Um, sorry, my notes don't make sense here. Let me consult where I actually wanted to pull this from. Times 1 over P. Oh, and this will just be 1. And so dq dp should equal alpha Q over P. That's my fault. I had a term that was kind of floating around over here, but we should be fine here. This should be good. So dq/dp is equal to this as such. Um, and so remember that epsilon was dq/dp p over q. So if we multiply both sides by p over q, we get that epsilon is just equal to alpha, or a constant elasticity of demand. And so this would happen when, like, this would be the only case in which our elasticity would be constant across the board. So we have a couple other elasticities. We have this thing called the income elasticity of demand. Again, this is going to be the kind of the same concept from when we have from beforehand, but the only difference is that we're looking at changes in income rather than changes in price. This is what we're going to call a Z or a chi, Z, whatever you want to call it. Squiggly E again. They all look kind of like squiggly E's. Um, you won't really need to know that. You can call it income elasticity of demand. It'll be fine. I will always refer to it as income elasticity of demand. You don't have to like remember Greek. This is not a Greek class. Other ones are cross price elasticity of demand. So imagine we wanted to look at what happens to quantity demanded as substitutes or complements change price, right? So not the own price of the good, right? So the percent change in quantity demanded following the percent change in the quantity of the substitute is going to be PS, and the percent change in quantity demanded following a percent change in the price of a complement should be PC. And so this should be positive, right? If we think about the price of a substitute increasing, we're going to be more likely to be looking at our own good. But the price of a complement, which is going to increase the price of our good, is going to cause this to decrease. And so our cross price elasticity of demand is going to be decreasing. So if we wanted a quick example, we would have Q equals 8.5 minus P minus 0.3 PS plus 0.2 PC plus 0.1 Y. If we wanted to find the eta, wow, that was bad. Not eta. Sorry. Our funky E, income elasticity of demand. Um, then we would look at the partial of Q with respect to Y times Y over Q. And so our partial with of Q with respect to Y is just going to be 0.1 times 35 over 10, which should equal 0.35. Then if we wanted the price elasticity of demand for substitutes, we would take dq, dps, ps over q, and we're going to look here to be minus 0.3 times 0.2 over 10. This is going to be minus 0.006. And then I'm going to let you guys fill in the blanks here. This should also be 0.006. No, it should not also. This should be positive 0.006. I lied. And because I screwed up on that, I'll just do it. This is going to be 0.2 times 0.3 over 10, 0.006. So we're good. It's going to be positive. The last elasticity that we're going to look at is this thing called the supply elasticity, which, again, very, very similar to the demand price elasticity of demand. We have the price elasticity of supply is just the change in quantity supplies following a change in price. And so that's going to end elasticities, and we'll move into sales taxes.